And this is the second model problem on the lesson. And this one is going to model exponential decay. And the way we find our common ratio, as mentioned in the last video, will just be a little bit different. So we have 50,000 deer in an area, and the population is decreasing at a rate 4% in each successive year. Write a geometric series formula, S subscript n, for the total number of deer over n years. So they want us to come up with a very general formula. So we're not actually going to be subbing anything in for n just yet. We are going to be substituting in everything else except for n. So our first term is 50,000. And that again goes in 2 locations. The common ratio. So the common ratio for us, because we're talking about exponential decay, is going to be 1 minus the yearly percent decrease, which was 4%. So as a decimal, that's 0.04. So the common ratio for us is going to be 0.96. We're not subbing anything in for n just yet. We're coming up with a general formula. And that's exactly what they wanted for part A. Part B, use this formula to find the total number of deer in 13 years, rounded to the nearest integer. So now we are going to be substituting in 13 for n. And then just again using alpha y equals enter, throwing in the values exactly like you see them on your paper. And then we're going to think about our answer, because sometimes when students get this answer, they're a little bit confused by it. So we wind up getting 514,748 deer. They wanted us to round to the nearest integer, which is the nearest whole number. So the reason why some students who are logically trying to make sense of their answer, they're a little confused because it said that the population of the deer was decreasing. And if we started with 50,000 deer, how can this number be 514,000, which is a lot more than 50,000 deer? But again, you have to understand what this formula is finding. This is the total amount of deer in all of the 13 years. So what happened is this number represents the 50,000 found in year 1, plus, now, in year 2, the amount of deer is for sure smaller than 50,000 because we do have exponential decay. So let's just, 40-something thousand deer, right? But those two quantities together are 90,000 plus deer, right? So this is the summation of year 1, year 2, year 3, year 4, all the way up till you get to year 13. So it does make sense that this is a higher number. Again, because this does not represent the amount of deer in year 13. It represents the summation of deer in all of the 13 years. So I hope that helps you to better understand what these figures are really representing. And there's your model 2.